Okay, so we are going to take the speed clip that you've just seen and just ask, is the physics reasonable? So let's just discuss a little bit of the setup here. So you've got a bus that's going at, 55 miles an hour? And they want to, they're coming up to a gap in a road. So there's a road and there's a gap. They very specifically, like, what is a gap? And they say very specifically, it's 50 feet. So the 50-foot gap in the road. Okay, so so first of all, let's just think about if we've got a highway with a gap, and your bus or your car or your bike or whatever you're on goes off the edge. Is that bus going at 55 miles an hour or whatever the speed is, and actually we'll see in a second the speed isn't 55, is it going to make the jump? And the answer is, doesn't matter how fast it's going, right? That if I've got an object going off with an initial horizontal velocity of v0, it has got to, because of the Earth's acceleration due to gravity, regardless of how fast it's going, it's got to fall. So there's no way to, first of all, right, whenever you see this in the movies, there's no way to make a jump if you've just got a horizontal velocity and you're trying to cover a gap. There's no way to make a jump. So you've got to. So what can we do in order to make a jump? You've certainly seen people in real life making jumps before. So how do you jump over a gap, or how do you jump over a distance? Well, in order to jump over a distance, you've got to get at an angle, right? So you've got to take off at an angle. If you take off at an angle, now we can make a jump. And so they actually are very clear in the movie. They take that into account, and they literally say, it is an interchange. There might be a ramp. Well, this makes no sense to me at all. I have no idea what they mean by there might be a ramp. But whatever. Let's just give it to them. There might be a ramp. So let's put a ramp in here. So, and you can actually go ahead, because I'll tell you right now that this jump was actually done. Or a jump was actually done, not this jump. A jump was actually done. With a stunt driver and a stunt bus. With no people on it, and there was no gap in the highway, but a jump was done. Oh, how did they get the gap in the highway? They CGI'd the gap out. So they did Los Angeles highways. It was actually real film footage of a closed highway in Los Angeles, but they CGI'd out the gap. There was no gap. Okay, so in reality, they took a bus and they jumped. But in order to make a gap, you've got to have an angle.
How many stars would you give?
So they specifically say there's a ramp, so the initial velocity is at an angle, it's not horizontal. Excuse me. So the bus can make some kind of a jump. It's not going to just fall immediately into the gap. So you can actually go ahead and you can measure the angle. You can stop. I have done this. I've stopped the video, and you can measure that angle to be 15 degrees. So there is a 15-degree ramp that the bus is taking off on. The other thing that Jack says, Jack, is that his name? I forget. The dude on the bus, what's his name? Famous movie star, says to the famous movie star driving the bus, is floor it, right? Go as fast as possible. So the bus isn't going 55 miles an hour, but the bus, they actually show you the speedometer, and we see that the speedometer says 70 miles per hour when the bus hits the ramp. Okay, so here's the situation. Bus is going off on a ramp, 70 miles an hour, at an angle of 15 degrees. Does it make the jump? So the question is what question do we want to ask? Excuse me. What question do we want to ask? What do we want to solve for, right? We've got this kinematics problem set up, and what do we want to know? Oh, well, we want to know how far can the bus jump? So we want to determine what delta x is. Delta x, how far the bus can jump, right? Boop, 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 boop. Now let me do that in a different color. So The bus is going to follow some parabolic trajectory. And the question is, and it should be symmetric, but anyway, the question is how far can the bus jump? This is actually something which in physics is called the range. Delta x is the range. We want to know the range. And some of you, if you've taken physics in high school, might have learned the range formula. I do not know what the range formula is, and I'm not kidding. I don't know what the range formula is. I've never used the range formula because we will just do regular kinematics to figure this out. So we want to know what is delta x. How far is the bus going to jump? And, jumping right ahead, we want to know if that's bigger than or smaller than 50 feet, right? So we're going to find the range. So let's see. We've drawn our picture. Let's start from the beginning. Draw our picture. We know that you've got acceleration down of 9.8 meters per second squared. Try to include everything. We got to choose our positive directions. Since the bus is going to the right, we might as well make to the right plus x. And then up or down. Do we want to make up or down plus y? Doesn't matter to me. We just got to just make sure we take into account the fact that the acceleration is down. The initial velocity in the y direction is up. So one's going to be positive, one's going to be negative. Doesn't matter. I wish I had you to tell me which direction you want to be positive. Hey, let's make positive y down. Okay. Positive y is down. So now we can go ahead and write our equations. So, I'll even forget delta x equals question mark. Let's just go ahead. We're setting up a problem. Write our equations. Delta y equals 1/2 at squared, a sub y, t squared plus v0y t. Vy equals v0y plus a sub y. A sub y t. Vy squared equals v0. Oh my goodness, it's not writing. v0y squared plus 2 a sub y delta y, and delta x equals v0 xt. So those are our 4 kinematic equations for projectile motion, right? Special case of projectile motion. We've got 4 kinematic equations. So then we identify what we know and what we don't know. So the next step, right? Step 1 is draw our picture. Step 2 is draw our axes. Step 3 is write down our equations. Step 4 is identify what we know and what we don't know. So let's just start with looking at our equations. Delta y. Do we know what delta y is? Do we know what delta y is? Well, look at the starting position and the finishing position of the bus, right? The bus starts and finishes at, we can just call that, right? I just filled in the gap. I didn't mean to do that, but, oh, come on. Let me undo that. Delta y is 0. It starts and finishes at the ground. Delta y is 0. A sub y. A sub y is, since down is positive, it's positive because it is down, 9.8 meters per second squared. T, do we know the amount of time it takes to do the jump? No. V0y, do we know V0y? Well, we don't know V0y directly, but we do know V0y from the picture. So this is what we should always do. So there's a step 5, or maybe it's a step 3.5 or 1.5 or 2.5. We do it in here somewhere. Somewhere we need to take components of all vector quantities. We need to take components of all vector quantities. I'll just call that step 5, components of vector quantities. So we need to take components of vector quantities. So I'm going to go ahead and draw right on my picture. It's a little bit messy, but we're going to draw components. Now, we chose our down as positive y and to the right as positive x. So I'm going to go ahead and rewrite that actually over here. Plus y plus x. And here's my v0. v0 equals 70 miles per hour. And theta is 15 degrees. Okay, so I did SOHCAHTOA for that triangle to find the components of the initial velocity. I guess these should be v0x and v0y. Okay, components of the initial velocity. I didn't do the math out, but 70 miles an hour, cosine 15 degrees to the right, and 70 miles an hour, sine of 15 degrees up, which is going to give us our sines. V0x is going to be positive, and v0y is going to be negative, since down is positive. So we want to plug this in.